Hey everyone, thank you all again for coming to the Whitebark Pine Ecosystem webinar. I think we have most everyone logged in now, so I'm going to go ahead and start the webinar. My name is Lou Deloise. I am a PhD student in Danielle Ulrich's lab at Montana State University. I am co-organizing this webinar with Laurel Sindwald, a recent PhD graduate from Dr. Diana Tombach's Forest Ecology Lab at CU Denver, and Enzo Martelli Moya, a PhD student in Kara Nelson's lab at the University of Montana. If you missed any of our previous installments, you can find the recordings of our talks on our YouTube channel. I will put the link for that and our website in the chat as soon as I'm done introducing our speaker. So it is my pleasure to now introduce today's speaker, Dr. Sara Goeking, who is a Forest Inventory and Analysis Program Manager with the U.S. Forest Service. Dr. Goeking has a doctorate in watershed sciences from Utah State University, and her current work utilizes forest inventory analysis data to address current and future management challenges in order to provide transparency and accountability to the public and Congress, and to advocate for fair data principles so that FIA data and analysis are accessible and repeatable. Before we jump into Dr. Sara Goeking's presentation, we are going to have an update from Glenda Scott.
Well, good afternoon. We want to thank you. I'm on the board of directors with the Whitebark Pine Foundation, and I just want to take a couple minutes at the start of Dr. Goeking's presentation. The foundation we proudly sponsor this seminar series that Laurel, Lou, Enzo have been organizing, and all the speakers that have been so generously giving of their time to share the science and current management. So it's great to be here for a few minutes. One thing I want to make you aware of, if you're not, is that annually the foundation awards a $1,000 to $2,000 grant to PhD or graduate students, undergraduate and graduate students, master's and PhD, for conducting research in whitebark pine. After 2024, it's likely that it'll change to all high five species, but right now it's still with whitebark pine research. And I'll put the a link into the chat box after I'm done on going to the Whitebark Pine Ecosystem Foundation website and getting that application. It's a great opportunity to share the science. It's a big part of our mission to promote scientific advancement of management and restoration. And then secondly, then to bridge that into management actions. So we hope that you will consider that opportunity to gain a couple of $1,000 perhaps in all aspects of whitebark pine scientific knowledge. And also specifically, there's one from a private donor on climate change in whitebark pine. So with that, I'm going to turn it back. I hope that if you want to be a member of the Whitebark Pine Ecosystem Foundation, again, our mission has changed to include all high elevation 5-needle pines. So that's both bristlecones, fox pine, limber pine, whitebark. Which one am I missing? Something. Oh, a Southwest white. So there's a lot of opportunities for research, and I hope that you will take an opportunity to apply for that. I want to tell you that that's due March 1. The application will be on the website link that I put in the chat box. And if you'd like to be a member, I'll put that link also, and you'll be first to get the Nutcracker notes each year and be able to support the management and science to promote the conservation of whitebark and high elevation pines. So with that, I want to get on to the program. Thanks so much.
Okay, slide check. Can I get a thumbs up? Can you hear me? See my slides? Thank you. Great. Okay. Welcome, everybody. Thanks for being here. I'm Sara Goeking. I'm the National Program Manager of the Forest Inventory and Analysis Program. And before that, I was at Rocky Mountain Research Station for almost 20 years, where whitebark pine was something that I sort of accidentally got into studying. Before I begin, I want to really thank the people that invited me to speak here today. Also, I renewed my membership to the Whitebark Pine Ecosystem Foundation last week, and I very much appreciate the work that all of you do. So thank you. You all give me a lot of hope. And by the way, I'm talking to you today from Logan, Utah, on the unceded lands of the Shoshone and Bannock people. So this all started, what I'm going to tell you about today, the work I'm going to summarize, started with a forest inventory and analysis crew leader who was on a detail to Rocky Mountain Research Station about 10 years ago. She had done a master's degree with Connie McAfee, and she was interested in seeing where whitebark pine seedlings were found. And she said she suspected, just based on her experience as a crew leader, that there were a lot of whitebark pine seedlings in places that people maybe weren't looking or not looking closely for them. So we started a project to look at where seedlings occurred across all FIA plots. Since then, I've worked with some other people from Rocky Mountain Research Station, Forest Inventory and Analysis, including Rachel Simons, Kyle Dodson, Jeremy Marone, Jim Steed, and Shayla Williams, and they continue to use the forest inventory data to do periodic assessments of the status of whitebark pine. I also want to thank Matt Lavin at Montana State, who has done some lab analysis to verify IDs of samples on FIA plots. Also Sean Parks, who's a collaborator from Rocky Mountain Research Station. Other FIA, Forest Inventory and Analysis people from Pacific Northwest Research Station, and then also all the National Forest System regional contacts that have given us input on what would be useful for them to see from the data that we're analyzing. So, so instead of us kind of doing our analyses and writing in a vacuum, making sure that we're addressing a need. So the take-home points, I want to, first tell you what I'm going to tell you. The main points are, first, that whitebark and limber pines have declined steadily throughout their ranges, both in terms of numbers of live trees and growth and mortality rates. We know that more than half of all standing whitebark pines are dead. That's been the case since 2016. And almost half of limber pines are dead. I'll talk more about that too. Also, another point is that regeneration is most abundant in forest types dominated by species other than five-needle pines. And then finally, the third point is that FIA is going to continue collecting data, and it offers analysis-ready data for broad-scale assessments and detection of trends across all forest type and management categories. So before I dive into what we have learned about whitebark and to a lesser extent limber pines from forest inventory data, I want to talk a little bit about the FIA program so that you have an idea what it's good for and maybe where it might fall short or other data sets or studies might be more useful. Okay, so FIA collects, processes, analyzes, and reports on the extent and condition of forests in the United States. The Forest Service is designated as a federally designated statistical agency because it encompasses the FIA program. FIA is mandated to improve understanding and management of forests in the US by maintaining a continuous and comprehensive inventory of status, condition, and trend in health and diversity of our forests. FIA has done some sort of inventory since 1930, although the sampling methods have changed substantially during that time from an aggregate of locally conducted inventories to a nationally consistent sample and plot design starting in the year 2000. So we measure how much forest exists, where it exists, what's growing there, how fast it's growing, who owns it or manages it, how is it changing, how much has died or been removed, and what is killing it. FIA is actually implemented regionally by 4 different regional units. And before we started this nationally consistent sample and plot design that I mentioned, it was executed at an even finer scale than this. A lot of individual forests or regions did their own forest inventory. And since those days, we've been continually trying to become more and more consistent, so that, say, if you're working in Montana and you're collaborating with someone in California, you can have the same access to the same data, the same variables, and use the same analysis techniques to get comparable, to get answers that you could actually compare to each other reasonably. So we say that FIA is an annual inventory, and we don't measure all of our plots every year. What the annualized inventory means is that a set of plots is measured every year. And here I've shown some hexagons just showing what that looks like in space. Each year in the Western US, 10% of the plots are measured. And these hexagons, I'm showing a couple counties here, one in California to represent how we do this in the Western US. Each year, we move to a different color represented by those hexagons. And the hexagons are numbered so that we're never measuring 2 adjacent hexagons in consecutive years. We call it a spatially interpenetrating panel, basically trying to ensure or maximize the representative aspect of the sample, not only in space, but also in time. So it takes us 10 years then to measure all plots. And this is what the plots actually look like. We have 4 subplots. They're 120 feet apart. The spacing between the plots is on average about 3 miles, and the plots cross not only national forest lands, but all lands, as long as we get permission from the manager or owner to go to those places. So we actually work with the National Park Service, with individual park units, state agencies, private companies, tribes, and individual private landowners to get permission and access plots in a way that's acceptable to them. Anytime someone says they don't want us to go to a plot, that if we have coordinates in our sample design that fall on their land and they don't want us to do that, we respect that. That's their prerogative. And then we also maintain confidentiality of any private owners that do allow us to measure plots. So on each of these subplots, we measure a lot of tree variables, dozens of tree variables. We also measure regeneration on these smaller, the little black dots called microplots. On the full blue plots, we also measure understory or non-tree vegetation. We record some land use and land use change metrics for areas that maybe were forests but no longer are. And then some basic stand characteristics, as well as growth and mortality and removals of trees. And when I say trees, usually, so on the main subplots, anything that is at least 5 inches in diameter at breast height has the full suite of tree variables measured. Anything smaller than that, that is measured and counted then on those microplots in black. So now I'm going to get a little bit into the weeds just momentarily on how FIA produces estimates. And the reason why I want to get into the weeds for just a minute is to get to where I can describe what FIA data are good for and where we might be asking too much of the data. So first, for each plot, stand level or tree level measurements are aggregated to the plot level. So then all of the plot level estimates are extrapolated at the stratum level. So we have this map here. These are our strata. This is not a stratified sample. It's stratified. It's post-stratified estimation, which is different than a stratified sample. And we're doing this to reduce the variance and increase the precision of our estimates of whatever variable, whether it's forest area or number of trees, number of dead trees, growth, things like that. So each plot represents roughly 6,000 acres on the ground. So when I say they're extrapolated, we use expansion factors to get an estimate of, okay, how many acres does that one plot represent? Then the third step is actually summing all those stratum level estimates of the different attributes and also calculating the sampling error based on the variance. So now to zoom back out from those details, we can produce estimates that meet the needs for precise and unbiased data at regional to national scales. Within the Western US, typically a county is about as small as we can get. Often a national forest is as small as we can get. Some national park units, some of the larger ones. When we start looking at finer scales than that, then the sampling error can often be quite large. And then that raises the question, is a really imprecise estimate with a large sampling error useful? Is it better than no number at all? And I think it kind of depends on the specific use of the data. So, and I'll just mention that we're moving from these estimates. This process is what we call design-based estimation to model-based or model-assisted estimation. And what that means is we use other data sets, other auxiliary data. So more satellite imagery, probably elevation, and a few other variables with some statistical models to come up with a map of some attribute of interest. Right now, we're working on forest area and biomass and carbon maps that then allow us to estimate more precisely at finer scales from that map and also be able to estimate the error associated with those estimates. But those methods are not yet mature. And so whenever we are asked, can you tell me how many whitebark pines I have just on my district or on, my small, if it's a relatively small national park or a small watershed, often the sampling error is going to be higher than I think most people would consider acceptable. So in the future, we hope that we can use this model-based or model-assisted method. But for now, really, the strength in FIA data is looking across these broad scales. So, and now I'm going to repeat myself because I'm getting ahead compared to what's on my slides here. Okay, so it's representative of conditions across the landscape. This is a probabilistic sample. The estimates have been demonstrated by statisticians much smarter than I am, that they are unbiased estimates. We also can quantify the data quality that were used to produce these estimates. FIA has a QA/QC program that I'll talk a little bit about with respect to whitebark pine. It's also funded in the future in perpetuity. FIA's funding, it goes up and down like any federal entity's budget, but it's pretty reliable that it's going to continue to exist in the future. The data are also published online. There's the FIA Data Mart where you can actually access the relational database and download individual tables for each state, or you can use the eValidator estimation tool to just get an estimate at a broad scale. A lot of the work I'm about to present was done using eValidator. I use it as much as possible because I want the data to be something that anybody else could reproduce, whether just to verify my results or to do it again in the future, or for a specific area of interest that I maybe didn't include in a paper. So some limitations is that we don't yet have great methods for doing finer scale estimates. Also, these are observational monitoring data. So in terms of inferring causation, really we're pretty limited to correlation between things that we observe rather than causation. So, I mean, that to me says that this complements finer scale and experimental studies quite well that are better suited to look at mechanisms and drivers. Also, the FIA sample design isn't optimized for monitoring mortality agents that can affect and kill stands faster than an FIA remeasurement cycle. So if white pine blister rust is coming into a stand and is killing trees, and evidence of blister rust in those trees is gone before a crew comes back, you know, over that 10-year interval, then that won't be recorded for those trees. So you know, I tend to think that FIA data underestimate the prevalence of blister rust, at least in places where it attacks fairly quickly. Finally, access to the precise location data requires formal agreements. We have had people use FIA plot locations to do like modeling of FIA or of whitebark pine locations, both for mature trees and seedlings. The reason why the data are protected, they're protected by law for two reasons. One is to protect the privacy of landowners that allow us to access plot locations on their land. And then second, to maintain the integrity of the sample. There have been a few documented cases. They're isolated, but they actually have had the potential to have a big impact, where someone managed these locations differently in order to, you know, sometimes they were well-intentioned, thinking, well, we don't want to affect your study. And it's like, the idea is that anything that a landowner or manager would do, we want them to do anyway, so that it is not biased by the fact that we have a plot there. So now I'm going to get into some findings that we've published over the last few years, and some ongoing work with forest inventory and analysis data. The first part I'm going to talk about is mostly found in two papers that I've shown here, and I'd be happy to share links to those also. One of those, the first one, is in an open access journal that anyone should have. You shouldn't have to pay to access it. It's not behind a paywall. The second one might be, and because we're federal employees, that is also available on a Forest Service website for anyone to access. The main objective in these papers was to characterize the broad scale demographics and trends in some key metrics related to whitebark pine. The first was just the area of land with whitebark pine present by forest type. We also looked at the abundance, the numbers of trees in total by diameter class, including seedlings and saplings, and also by forest type. The paper that I showed that's in Forest Ecology and Management, I'm not going to present this today, but we also looked at density and didn't find a lot of dramatic patterns there, not a lot of significant trends over time in densities. We did find some important changes in growth rates relative to mortality rates. And also we looked at causes of mortality. So I'm going to present some results today that are mainly pre-2010 and then 2010 to 2019. So that's a whole FIA measurement cycle where all the plots were measured. So the area of forest with whitebark pine present, this means that any whitebark pine, seedling, sapling, or tree size is present on the site. And 15% of the total area with whitebark pine present exists in the whitebark pine forest type. So that means that 85% of the area with whitebark pine present is actually a different forest type. And of course, the densities of whitebark pine trees are lower in those forest types. So things like, you know, that might mean that Clark's nutcrackers are not as readily attracted to those sites if they're looking for a particular density of whitebark pines. But related to this, we found that less than 1/3, 28% of all whitebark pine seedlings occur in the whitebark pine forest type. So not only is there more area, but there are far more seedlings in other forest types than in the whitebark pine forest type. The main forest types where we're seeing lots of whitebark pine are lodgepole pine. That's far and away above the rest, but also Engelmann spruce and subalpine fir, and then pure subalpine fir stands. So here I'm just showing plot locations as of 2016 that had been measured by FIA that had whitebark pine present. Again, this is using the publicly available data. We summarized the percentage of total whitebark pine basal area that was alive. And so here you can see, the hot spot of mortality in the crown of the continent at that time. That if we produce that map today, it's a little bit more severe. I do want to mention also, because of the COVID-19 pandemic, we were delayed in data collection over the last 3 years, and we're currently waiting for the catch up of those data. The data have been collected and they're now going through QA, QC, and expected most of them will be published this spring, so that we'll be able to update some of these things. So here's the size class distribution. I said we looked at numbers of trees, and here I looked at some of our pre-2000 inventories. I mentioned that the FIA sample design wasn't nationally consistent before that time. So instead of looking at total numbers of trees or total area, I looked at the proportion of whitebark pines in each size class. And I looked at live and dead trees separately. And as you can see, in 1999, there were far more live trees than dead ones. And by 2016, that had changed. So at that time, there were still lots more in the smallest size class. The smallest size class that I'm showing here is the 5 to 7 inch category. So that's the smallest of the trees measured on a full FIA subplot. When we look at that same metric, so here we're looking at the numbers of live and dead trees again. We see, and here we're looking at the same, the decadal time periods that I mentioned, and I'm showing limber pine as well. And the number of dead trees for both species increased, often significantly, between pre-2010 and the past decade. Okay, I'm going to move on now to seedling abundance. This is showing seedling abundance by forest type. So this is the estimated total number of seedlings across the landscape. So again, these are, estimates produced using that process I mentioned, where we aggregate at the plot level, expand, and summarize across broad areas. So for whitebark pine, there are more seedlings in the lodgepole pine forest type than in the whitebark pine forest type. Limber pine is most abundant in lodgepole and Douglas fir forest types, and then the limber pine type. When we look at the change in seedling and sapling abundance between these two periods, there weren't any major changes there. So that is actually a good thing, even as we're seeing some significant changes in the numbers of trees in the larger size classes. So 5 inches and greater, we are not yet seeing that in seedlings and saplings. So these are 3 different, what I'm showing here, the first set of bars is anything that qualifies as a seedling. So for FIA, these are at least 6 inches tall and less than 1 inch DBH. Then the second and third categories are 1 to 3 inch saplings and 3 to 5 inch saplings, and no changes really in any of those categories. So that's a good thing. So here, now looking at growth and mortality. This is kind of an old school forest inventory metric, but I think it speaks volumes, literally, about the sustainability of any tree species. Usually historically, this has been used as an indicator of how sustainable a harvest is. So you want net growth of a species, or the total growth of the species, to exceed what's being cut. But in this case, we're looking at mortality, because this isn't being cut for commercial purposes, but it is dying at high rates. So here, growth and mortality, they're expressed as volumes. And that is, I already talked about numbers of trees, and most tree species have lots of small trees, and it's normal for there to be a lot of mortality of many, many, many small trees. So volume kind of normalizes for that and gives more weight to the larger trees. And this is from the Forest Ecology and Management paper, where we actually looked at 6 5-needle white pines in the Western US. Limber and whitebark are the 2 bottom ones. So that vertical line is the point at which growth and mortality are balanced. So at the very top, Rocky Mountain bristlecone has positive net growth. So growing, surviving young trees are more than making up for bristlecones that died in terms of volume. And that's not really surprising. We haven't seen a lot of mortality of bristlecone pines. It's more alarming to look at limber and whitebark pines, where the net growth, the growth minus the mortality, is negative. Mortality exceeds growth by quite a bit. And so seeing that they are significantly different than 0, they're quite large negative numbers. So, and I forgot to mention this earlier, I did put error bars on each of these representing a confidence interval. Okay, what's killing these trees? I mentioned earlier the caveat about blister rust and the 10-year measurement cycle. So you can kind of see what I was talking about here. I suspect I'm not sure if anybody has the data to show or to confirm that we're underestimating blister rust prevalence. This suggests that that's true, though. So here, looking at different mortality agents before 2010 and then 2010 to 2019. So disease, the main one being blister rust, is a pretty small proportion of the mortality agents recorded for all of these trees. And again, if blister rust appeared after a crew measured a plot and killed the trees, and there was little to no evidence by the time the crew came back 10 years later, it would not be recorded. Things that were recorded, lots of insects and some fire, and fire was recorded more often even than disease was. If anyone has any ideas about that limitation on recording blister rust, I've heard that in some areas, especially in the coastal states, it's more likely that there would be evidence of blister rust on the site for that 10-year return interval. But I'd be curious if anyone has comments or ideas on how to quantify and try to get a better understanding of how far short we're falling, or if at all, on quantifying blister rust. Okay, now I'm going to get a little more into the growth and mortality. I think it's useful to look at growth and mortality, and again, this is in terms of volumes, by size class. So on the left is growth and mortality for whitebark pine. Growth and mortality are approximately equal in that smallest 5 to 7 inch size class. All size classes bigger than that, mortality really, it dwarfs the growth of surviving trees. And it's you know, sometimes it's hard not to be really bummed out finding results like this. And it is alarming. I think it should be alarming. So then looking at limber pine, we see a similar but not quite as dramatic pattern. Growth actually exceeds mortality in that 5 to 7 inch size class, but it's smaller than mortality for all the larger size classes. So I also want to point out that in an earlier paper, which I've added a graph from an earlier paper here. On the lower left is whitebark pine from 2005 to 2015. And compare that to the upper right, which is limber pine for the past, well, for 2010 to 2019. So comparing those two, the patterns are quite similar in terms of having more growth than mortality in that smallest size class. It's not significantly higher for whitebark pine, but the pattern, you know, qualitatively at least, is similar. And then in the larger size classes, they're very, very similar patterns. So basically, the relative volumes of growth and mortality for limber pine over that 10-year period ending in 2019 really mirror those that whitebark pine experienced just 4 years prior. Okay, so next I want to talk a little bit about data quality and what we know, what we don't know, what we're working on quantifying in our data quality. FIA does have a quality assurance program that includes both quality control and quality assessment aspects. FIA crews revisit 10% of all FIA plots. So a second crew goes back to the plots on 10% of them for QA or QC purposes. So this is in addition to the extensive training that field employees go through. And when a crew goes back after the first crew measured the plot, they are doing an ongoing targeted review, and they're giving feedback on an ongoing basis to each crew. And the feedback is often given like by a regional supervisor. So when those crews go to a plot, if they're the second crew to go there, they are keeping in mind that we have measurement quality objectives for everything that we record or measure in the field. As an example, for diameter, we want to be within 0.1 inch for every 20 inches of diameter of the tree. And we want to achieve that goal 95% of the time. So we have two things we're looking for. Is it within that tolerance that we set? And is it within that tolerance, you know, whatever percentage of the time? So after we've done this at lots of plots, we report and publish on the results of the data quality assessments. Here I've pasted a table. This is from an older assessment that was nationwide, so it's not targeted on whitebark pine. But I wanted to mention that Rachel Simons, who is the quality assurance coordinator at Rocky Mountain Research Station, FIA, she's working with others on a systematic report of the compliance rates and the quality assessment results. So stay tuned for that. I think it's a good thing to use these results to identify where we're falling short and where our strengths are in terms of the quality of the information that we're collecting and reporting. One thing that we've also been doing is collecting samples and sending them. I mentioned Matt Lavin's lab at Montana State. He's been using the test developed by Franklin Alongi et al. To verify the species identifications. We had almost 300 samples that were collected for a different purpose about 10 years ago. And they were collected from all FIA plots of all species. And when this test was developed, we said, well, we have all these samples, maybe we should use them and see if we can analyze them using this test and verify how good are our species identifications? So we found that out of the trees that were identified by field crews as whitebark pine, 99% of them were correct. Of the ones that were limber pine, more than half were correct, and it varies by size class, but a lot of them were actually whitebark pine. So we found that plots where both whitebark and limber pines occur are more common than we thought, and that often the accuracy of the species identification was affected by the presence of mature trees of either species. So if a crew saw a mature tree and there were cones present, we suspect that they're assuming like, okay, that's what is here. So since then, we've started collecting targeted samples within the area of range overlap of these two species. In 2023, almost 500 samples were collected, and overall accuracy was 88%. And again, anything identified as whitebark pine was that was close to 100% accuracy. It was when things were identified as limber pine that were actually whitebark, where we had more errors. So we're still working on this analysis and what it means for the estimates and the data that have already been published. So there's some other ongoing work that I want to summarize briefly too. We have some, we plan to do periodic updates and keep coming back to some of these milestones or earlier trends that we observed. We also are doing assessments for individual management units that need to respond to the listing and do various types of formal reporting to the Fish and Wildlife Service. Then there's also some climatic suitability modeling work going on with FIA data. So the ongoing monitoring, I want to say first that this statement about more than half of all standing trees being dead, it's not big science, but it really got people's attention. And so I keep coming back to well, where are we with these things that clearly are getting people's attention and being used in some of these high level designation and management decisions. In the 2017 Resources Planning Act Forest Resources Report, we had a little section. This was like a 2-page section on at-risk forests. And this was where I first looked at the simple metric of what percentage of the trees are alive or dead. And at that time, we had data through 2015, and for whitebark pine, it was 49%. And I thought that was dramatic. Limber pine was 38%. By the time we did the paper that was published in 2018, the number for whitebark pine had crossed the 50% line. And as of 2019, it went up a few more percentage points, and so did limber pine. So again, not far behind. The steps that they're taking are similar sized. Whitebark pine and limber pine are taking similar sized steps with limber pine just appearing to lag behind where whitebark pine is. We haven't yet had data published, as I mentioned earlier, for 2020, 2021, 2022, and we're expecting to get a lot of that data in the next few months and revisit these numbers. So, this is just really a rhetorical question. Like I said, finer scale studies and experiments are critical for understanding drivers and mechanisms. But this has been a powerful statement, just being able to put a number, a dramatic number on how many whitebark pine trees have died that the Fish and Wildlife Service included in their assessment. And lots of media stories too, which has been kind of a surprise as to all the different research and science you can do and what do people pick up on. But I think that some of these talking points actually matter. They get people's attention. So the second ongoing work I wanted to talk about was assessment for individual management units. We're trying to help national forests and other entities respond to the listing and do their reports. We have some principles. We want the analyses we do to be scalable because first, if we conduct custom analyses for each management unit, but continue doing national ones, anybody could actually compare those and potentially recognize that there are differences, and they might not recognize the nuances of, well, maybe we didn't do the analysis exactly the same in different areas. So we really want them to be comparable and scalable across units and across scales, just to avoid any appearance that there are discrepancies in the data. So FIA data, like I said, have been used for the mature and old growth forest assessments and carbon assessments. And with anything that is that big of an issue of concern, we do need to make sure that the work is reproducible. So we're also trying to use online tools wherever possible so that these are repeatable analyses and can be redone in the future as we get more data. So the flip side of this is that managers do want fine scale data that informs their project level planning. And at a certain point, we have to ask how few plots is too few for reliable assessments, but also is any estimate better than no estimate? So for this process, we reached out to Forest Service regional contacts in Region 1, one district of one forest that has whitebark pine in Region 2, and then Regions 4, 5, and 6. After talking with all of them, we came up with a list of attributes. These are mostly the same attributes that I talked about earlier, and we're summarizing them at different spatial scales. So I was kind of surprised to learn that, the numbers of trees are the main metric needed for reporting to the Fish and Wildlife Service. And again, these spatial scales, we're always asking, at what point are there too few plots in a category we're trying to report on? So we've done some of these assessments, and we're going to be doing a workshop sometime this winter or early spring on how to do this for whatever your area of interest is using our online tools. And if anybody is interested in that, you can send me an email and I will be sure to include you on a distribution list when we do that. Climatic suitability modeling. This is something that Sean Parks at Rocky Mountain Research Station is leading with several collaborators. This is similar to the work that Tony Chang and others did for the Greater Yellowstone ecosystem a few years ago, except it's going to be for the entire US range of whitebark pine and entirely based on FIA data. Prior to starting this project, we'd gotten requests for a model based solely on FIA data. And our goal here, we know that other people are doing species distribution models, maybe not necessarily climatic suitability, but we're trying to avoid duplication of effort and be inclusive in addressing broad scale needs for projections. So this effort will produce maps then and projections across all forest types and ownership categories, not just Forest Service. And I've included this quote from Wayne Gretzky, because the idea here, I think, is to make sure that wherever restoration efforts are occurring, wherever we're focusing time and energy, that those are the places that are going to have the maximum chance that whitebark pine will survive in the future. So, where are those going to be? Maybe not where they were in the past. The final thing I mentioned is that we're working on, I'm part of a team working on the limber pine chapter for the updated Silvics of North America. We're collaborating with people working on other 5-needle pine chapters as well. And those, that update, the updated Silvics of North America, will include suitability models for the species that are included in that update. So again, back to where we started. Whitebark pine and limber pine have both declined steadily throughout its range. We plan to continue updating the analyses that we've done already so that we can see what does the future trajectory look like compared to what we've seen over the last 20 years. Regeneration is most abundant in forest types dominated by species other than five-needle pines. So by far, there are more seedlings across the landscape in other forest types, not just in the whitebark pine or limber pine forest types. That doesn't mean that they're at densities high enough to become whitebark pine stands, but there are a lot of individuals out there. And then finally, we're going to continue collecting data and to the extent that it's useful for assessing these broad scale assessments and detection of trends, we hope to support that however we can. So with that, you see my email is up on the screen. I encourage anybody to reach out if you want to talk more, if you have feedback or questions about any of this. And with that, I will turn it over to the Forest Service mandated disclaimer and turn it over to our facilitator to see if we have time for comments or questions.
Thank you, Sarah, for giving that excellent talk. We have a couple minutes for questions. So if folks have questions, please type them into the chat or wait and virtually raise your hand at the end of the talk so that Enzo can enable you to use your microphone. So I will go ahead and read some questions from the chat for Sarah to answer. Vincent would like to know if you can elaborate further on the hexagonal areas earlier in your presentation as they relate to plots and microplots and how they are related.
Good question, and I apologize I didn't state this more explicitly. Those hexagons are each about 6,000 acres or 2,400 hectares. Each one has a plot at a random location within it. So that is sort of a sample frame for the FIA sample design.
Awesome. Thank you, Sarah, for elaborating on that. Mandy would like to know if your findings can help with site selection for restoration plantings.
That's a good question. And I would say in a big picture sense, yes, as far as coming up with some guidance on what types of sites are likely to be useful for restoration. I would draw the line at suggesting, though, that they would be useful at identifying any specific location, although I do think that the climatic suitability model and map that is in development could be useful for that, because that will be fine resolution and will allow looking at specific points on the ground. Oh, and you're on mute, Lou.
Thanks, Sarah, for elaborating on that and for letting me know that I'm on mute. I think we have time for one more question, so I'll go ahead and just read the next one in the chat. Jessica is interested in knowing if direct planting of seeds is considered a good option for regeneration versus seedlings.
You know, that is definitely not my area of expertise, because we're doing this, broad scale monitoring and not the actual like management and restoration and monitoring of site specific restoration actions. But I suspect there's someone on the call that is expert in that. I also want to mention just briefly, I did see the note about a key for distinguishing the limber and whitebark seedlings. And basically our quality assurance specialist came up with a document that she compiled all of the existing literature on distinguishing the two species into a single guide with pictures for crews to use. Thanks for the questions.
Yeah, great. Thank you, Sarah, for elaborating on all of those questions. We only have a couple minutes left, so I'm going to go ahead and wrap up the webinar. Thank you so much for your excellent presentation, Sarah. Our next webinar will be on January 16th with Brian Smithers, who will be presenting his work on predicting subalpine forest pine mortality from drones and space. Thank you again, everybody, for attending, and we hope to see you all again next month.
Thanks so much.